Good morning, everyone. A very good morning. Shall we begin the session? Yeah, today's class is late due to some network error. So let's start with the session. Today's topic is a SQL data type, and in the last class we have finished about the topic. What are the various constraints? What are the various assertions? Okay, so we can wait for 5 minutes more. Okay, all right. So let's begin with the session. First topic is the SQL data type and the schema. Schemas means the structure. So what are the various data types that is required in SQL? And in addition to the basic data type that we introduced, SQL standard supports several data types relating to the dates and the times. So first one is a date, that is a calendric date containing a 4-digit year, month and day of the month. Then time, that is in hours, minutes and seconds. Then if I'm talking about the time P, that can be used to specify the number of the fractional digits for seconds, and it is also possible to store time zone information along with the time by specifying the time with the time zone. Then timestamp, that is a combination of the date and the time. So if I'm talking about the date, only the date that contains year, month and day of the month. Then time, that is in the hours, minutes and seconds. If I'm talking about the timestamp, that is a combination of the date and the time. And a variant, timestamp P, can be used to specify the number of the fractional digits for the second. And time zone information is also stored if with time zone is specified. And these values can be specified like this. This is the day 2001 425 9:30:00, then timestamp 2001 425 10:29 1:45. That means it is a hours, minutes, seconds. And dates can be specified in the format year followed by a month followed by a day. Yes, this is the followed by a month then followed by a day. And the second fields of the time or the timestamp can have a fractional part, and we can use an expression of the form cast E as T to convert a character string E to the type T, where T is one of the date, time or timestamp. Then string must be in the appropriate format as illustrated in the beginning of this paragraph, and when required, time zone information is also inferred from the system settings. And to extract the individual fields of date or time value D, we use an extract field from D, where field can be of the year, field can be of the month, day, hour, minute or second. That includes the day, time as well as the timestamp. And SQL also defines multiple functions to get the current date and the time. For example, if I'm talking about the current date, that returns only the current date. Current time, that only returns the current time. Local time. Yeah, this is as per the, no. Okay. This is as per the system's timing that returns. And if I'm talking about the local time, that it returns a current local time without any time zone. That may be a PST, that may be TST, that may be any timestamp. And timestamp, that date plus time are written by the current timestamp with the time zones, and the local timestamp, that the local date and the time. And SQL also provides a comparison operations on all the types listed over here. It also allows both the arithmetic and the comparison operations on the various numeric types. And SQL or SQL also provides a data type known as the interval that allows computation based on the dates and the times and on the intervals. For example, if I'm talking about the x and y of the type date, and then x minus y is an interval whose values is the value of the day or number of the days from date x to date y. Similarly, adding or subtracting an interval to a date or time gives back a date or the time respectively. That means it gives the value, it gives the time, it gives the interval when subtracting the values. Then next is the default value. So SQL also allows a default value to be specified for an attribute by using the create table command that is illustrated over here, that is defined over here. This is the create table student. We have created one table, that name of the table is the student. Now there are 4 fields over here. One is the ID, that is of the varchar 5, the name, that is of the varchar 20, that is not null, we are specifying, then department name varchar 20, then total credits numeric 30. So it is taking out the numeric values with no decimal values, and by default it is given as a 0. That means if nothing is specified, so it is given as a 0, it is used as a 0. Then primary key, that is ID. So we are specifying that the primary key in this table is ID field. And the default value of the total credit attributes is declared to be 0, and as a result, when a tuple is inserted, if no value is provided, then its value will be set out to the 0. And then following insert statement illustrates how an insertion can omit the value of the total credit attributes also. Now, this is one of the example. Insert into student ID, name, department name. There are three fields over here in the student table, and in the ID it is given as a value 12789. Then in the name, this is a Newman, and department name is a computer science. Yeah, there's a semicolon after the values. The next is the index creation. So many queries reference only a small proportion of the records in a file. For example, if I'm talking about a query, find all the instructors in the physics department, or find the total credit value of the student with ID 22201. That references only a fraction of the student records, and it is insufficient for the system to read every record and to check ID field for the ID or the building field for the value physics. Then we are giving the index on an attribute of a relation as a data structure that allows database system that allows the tuples in the relation, that allows the specified values for that attribute efficiently without scanning, without using each and every tuple, each and every rows of the relation of the table. For example, if we create an index, if we create a attribute or index on the attributes ID of the relation student, the database system can find the records without any specific or with any specified ID value. For example, if I'm talking about ID value, that may be a 22201, 12789 without regarding all the tuples of a student relation. Now this is the syntax. How to create an index. So this is a create index, student ID index on the student ID. So this is creating an index on the ID field. We can say this is just like a view, but this is not exactly the same with the view. The main benefit of using the index is that we are only specifying or we are dealing with only that field that is required. We are not dealing with the whole table. We are dealing with some specified fields. Example is, for example, if I'm talking about ID, that is 22201, so SQL's query processor would use the index student ID to find only the required tuple that defines with that ID, ID number, that is 22201. This is just one example. You can use any field. It's not mandatory that you're using the primary key only with the index field. All right. Any other confusion? Yes, right. Next is the large object types, that is not unit labels. Next is user defined. Like in C and the C++, we have studied about the structure, union, enumerators. In the same way, there is a data types that are user defined data types that also supports the SQL. So there are two forms of the user defined data types. One is a distinct, one is a structured. Structured includes the record structures, array, multisets. So have you read the data types of the SQL? Any doubts, anyone? Yeah, there are two types. One is a distinct, one is a structured. Structured includes the arrays structure that is similar to the C and the C++, only the syntax is different, concept is the same. Okay, so when we talk about the create type, that is the next part. So this clause can be used to define the new types. For example, create type dollars as numeric 12 to final, pounds numeric 12 to final. So this define the user defined types, dollars and the pounds to be decimal numbers with a total of the 12 digits, two of which are placed after the decimal point. And the keyword final is not really meaningful in this context, but is required by the SQL Stranded for any reason we won't get into here. So some important implementations also allows the final keywords and the newly created types that can be used, as well as the types with the attributes of such relations. For example, we can declare the department table as follows. This is the create table department name, varchar 20, 15, and budget for dollars. So this is an attempt to assign a value of the type dollars to a variable type pounds results in a compile time errors, because all the all the both are of the same numeric type, but there's assignment operators that is due to the programming errors. So where the programmer forgot about the differences in the currency. And declaring up different types for different currencies also helps catch such errors. And as a result of the strong type checking, the expression that can be used that would not be accepted, since the attributes and the integer constraint 20 have a different types. And values of one type can be cast, that can be converted to the another domain. Int can be converted into the float can be converted into int or any data type. For example, in this, there is a cast department budget, the numeric 12 and we could do addition on the number numeric types, but to save the result back to an attribute that is given over here, we could use another cast expression to convert type back to the dollar sign. And domains can have constraints such as the not null, primary key, data types, and domains are not strongly typed. As a result, the values of one domain type can be assigned to the values of another domain type as a long. Now let's see another example for the check constraints. For example, when we use a check constraint that can ensure that an instructor salary domain would allows only values greater than a specified value. So this is the create domain, yearly salary, numeric, 82, then constraint salary value test check value greater than 29,000. So whatever the value, whatever the data type that is used, so that is used with the yearly salary numeric constraint. Now it is checking out the value that is greater than or equal to 29,000. So this constraint ensures that the yearly salary is greater than or equal to 29,000. And the salary value test is also optional. It is not mandatory to give in this constraints. Any confusion in this example? I think this is clear because we have already studied the check constraints, where, having clause. Now, when we talk about the create domain, next example, degree level varchar 10, then constraint degree level test, then check value in bachelor's, master's, or the doctorates. Now, let's take about the next example, that is the create table extensions. Okay, so you want 5 minutes for, okay, you can take, okay. So let's begin again. Next part is a create table extension. So applications also often also requires a creation of the tables that having the same schema. Yes, that means now we're supposed to create duplicate data or duplicate table by using the like extension, by using the like keyword. So application offers requires the creation of the table that have the same schema on the existing table, and SQL also provides a create table like extension. So this is a create table temp instructor like instructor. So above statement creates a new table, that is the temp instructor, that have exactly the same fields, same data type, everything is the same as compared to the instructor table. And when writing a complex query, it is often useful to store the results of a query as a new table. And the table is usually the temporary table, and two statements are also required: one to create the table and second to insert the query result into the table. So there are two techniques. Let's take an example of the two techniques. So just to create table T1 as select strict from instructor where department name equals to music. So we're taking about each and every field by using the strict, by using the star from which table, that is the instructor, where the department name is music with each and every data. And by default, the names and the data types of the columns are inferred from the query result, and names can be explicitly given to the columns by listing the column names with a relation name. And as defined with the standard, if the data or with data clause is omitted, so the table is created but not populated with data. However, many implementation also populates a table with the data by default, even if with the data clause is omitted. Let's begin with the next topic, that is the authorization. So authorization means authority. So we may assign a user with several forms of authorization on the parts of a database that can include authorization to read the data, authorization to insert the new data, authorization to update the data, authorization to delete the data. There are four parts: read, insert, update, delete. Yeah, modify is same as the update. We can modify the content, we can update the content, that's the same thing. And each of these privilege or each of this authorization known as the privilege. So we can say privilege, we can say authorization, that depends on the requirement of the user, that depends on the client requirement. And we may also authorize the users with each and every one, none, or the combination of these profiles. That means at the same time we can read the data, at the same time we can insert, at the same time we can update, delete, or either only insert and delete, either update, delete. So we can use any combination, or we can use each and every combination on a specified parts of a database, such as a relation or the view. And when a user submits a query or an update, the SQL implementation first check out if the customer of the query or update is authorized or not. That based on the authorization, the user has been created. Now, if the query or update is not authorized, it is rejected. So it is first check one, or check out it is authorized or not. If it is authorized, then it is applicable, otherwise it is rejected. In addition to the authorizations on the data, and users may also be granted the authorization on the database schemas that allows them to create, modify, or drop the relation. Drop means delete the relation. Whole relation is deleted out from the database, but not the database is deleted out. Only the table bit deleted out. Now my question is to each and every one: what is the difference between delete and drop? I'm talking about what is the difference between the delete command and the drop command. Yes, right. Delete means deleting the contents of the table. Drop means deleting whole table or drop out the full table. That includes the fields, that includes the data type, everything is deleted out. And in case of delete, only the specified on only the content will deleted out, tuple deleted out, fields deleted out. And when I apply the drop, that means whole table, or we cannot use any table. And the ultimate form of the authority is given to the database admin, and that it may authorize the new users, restructure the database, and so on. So this form of authorization is also analogous to that of the super user, that is admin or operator for an operating system. First part is granting and revoking of privileges. That includes the privilege select, insert, update, delete. That includes the privilege that can be used as a short form for the allowable private privileges, and that can also includes or also creates a new relation that is given each and every privilege on that relation automatically. This is the grant privilege list on relation name or view name to user role list that allows the granting of the several privilege in one relation in one part. And select authorization on a relation is required to read the tuples and grant for granting the database users. For example, grant select on department to Amit and the Santoshi. Next is a role, that the roles will be assigned to the various people in a university. This is how we create the role. This is the create role instructor, then grant select on the takes to instructor, that is we have done. Then how to use the authorization on the views, authorization on the schemas, transfer of the privilege from one part to another part. Then revoking of the privilege. Revoking means taking out back the privilege. For example, I give the privilege to one of the person in the university, but that takes out in a wrong way, so we can take the privilege back also. This is a restriction in order to prevent the cascading revocation. So this is revoke, select on department from Amit Santoshi restrict. In this case, the system returns an error if there is any cascading revocations and does not carry out the revoke action. And this cascade can be used instead of the restrict to indicate the revocation that should cascade. And note that some database implementations do not support the above syntax. Instead, the privilege itself can be revoked, then granted again without the grant option. And cascading the revocation is inappropriate in many situations. Suppose one of the concerned person has a role of the dean, so this grant the instructor to the Amit, and later on the role dean is revoked from the Santoshi. This continued to be employed on the faculty and retained on the instructor role. So to grant a privilege with the database admin, with the session we can add the clause, this is granted by current role. Now at last there is a summary of this chapter. First part is SQL supports multiple joins, that includes the inner join, outer join, and the types of the join conditions. Then view relations, what are the views, how it can works out, how it can affect the result of the queries, how views are useful for hiding the unneeded information, collecting the information. Then transactions are a sequence of the queries and update that together carry out a task. The integrity constraint that ensure that changes made to the database by authorized users that do not result in a loss of the data consistency. Then differential integrity constraint that ensure that a value that appears in one relation for a given set of attribute that also appears in another relation. Then domain constraint that specify the set of the possible value that may be a attribute for the or associated with an attribute. Then assertions that are the declarative expressions. Then SQL data definition language that provides the support for defining built-in data types. Then SQL authorization mechanisms. Then user that has granted some form of authority. Then role that have been assigned with the set of the privilege according to the user, according to the role. These are the various questions. Next part is advanced SQL that I'm taking out in next class, that is in the tomorrow's class. Alright, so if there is any doubts, any clarification that you want on the assignment, that you want on this chapter, anything that you want to add, then you can clarify with the help of the chat.